Hello friends, if you're new to this channel, my name is Prasad Domla and I'm a senior cloud architect and DevOps engineer. And on this channel, I'll be talking about all things related to cloud computing, focusing mainly on AWS. Today, I'll explain the process of creating Lambda-backed HTTP APIs using AWS CDK and TypeScript. So let's dive in. HTTP APIs are basically lighter versions of full-featured REST APIs within AWS API Gateway Service. HTTP APIs are designed for low latency and cost-effective integrations with AWS services, including AWS Lambda, which we'll be using in this demo. Also, HTTP APIs support ODIC and OAuth2 authorization methods and comes with built-in support for CORS. There are some features which are not supported by HTTP APIs, like usage plans, API keys, request or response validations, AWS WAF integrations, etc. Also, HTTP APIs supports only regional endpoints and not edge optimized or private endpoints. AWS outlined all these differences between HTTP APIs and REST APIs in their documentation. You can have a look at those differences before deciding whether you want to go with HTTP APIs or REST APIs. I'll leave the link in the description. I've seen that in many projects we don't even use these additional features provided by REST APIs. So if you're in that group, HTTP APIs will provide more value than REST APIs in terms of latency and costs. Now let's quickly have a look at the demo overview. I'm using DynamoDB as my backend database and will be importing some mock user data which we'll be interacting with using our API endpoints. Next, we have 4 Lambda functions, one for each HTTP method, that is get users, add users, update users, and delete users. And these functions perform basic CRUD operations on our DynamoDB table. We'll also create a Lambda layer where we'll have some common utility functions and files, and we'll use this Lambda layer in all our Lambda functions. Next, we have a common IAM role, which is used as our Lambda execution role. Then we have Cognito pool, which we shall use for our API authentication. We'll do that using a Lambda authorizer function, which basically verifies the token we pass in our API requests with Cognito. Once authenticated, the request will be forwarded to respective backend Lambda functions based on the HTTP method. And finally, we have our HTTP API itself. I'm also using Route 53 for my custom domain. So this is optional. If you don't have a domain, you can directly use the API endpoint URL. And once we create all these resources using CDK, we shall test the API endpoints using Postman. So I'm on my VS Code here, and I'm using a CDK project I have already set up for my other video where I explained how to create Lambda functions using CDK in detail. So I strongly recommend to watch that video if you haven't already. I'll quickly go through the resources we defined in this CDK project so far. So in my tsconfig file, I added 2 keys, base URL and path mapping. And this mapping is required to make TypeScript happy for our Lambda layer. We are basically mapping our local Lambda layer directory to /opt, as all our Lambda layers will be mapped to /opt within Lambda runtime. In my cdk.json file, I define my context and set values for app name, region, and environments. Here I have only one environment, which is develop. If you want to know more about setting up multi-environment CDK projects, I have a video for that. I'll leave the link in the description. Next, within my lib folder, I have my Lambda config where I define my 4 Lambda functions: get users, add user, delete user, and update user. I've also created empty Lambda handlers for these functions within my Lambda handlers directory. We'll write some code in these Lambda functions later in this video. Within my Lambda stack file, I first defined a Lambda role and an inline policy, which will be used as the execution role for all our Lambda functions. Next, I defined our Lambda layer, and I'm just bundling all the files under Lambda layer folder and deploying it as a Lambda layer. Currently, I just have a utils file with some logger functions and type definition file. We'll add some more common utility functions to this file later in this video. Coming back to the Lambda stack, I'm defining our Lambda functions based on the config and creating respective log groups. Finally, within the entry point TypeScript file in our bin directory, I'm importing the Lambda stack and I'm fetching my environment specific context from cdk.json file based on my current branch. Within my create stacks function, I'm defining tags and stack props object and creating a Lambda stack. Those are the resources we'll initially create and add more resources and config required to create our HTTP API. So let's first deploy these initial resources using CDK deploy. Make sure you set your AWS profile before executing CDK deploy. The deployment is now finished and all the resources are created successfully. Now let's define our DynamoDB table and import some sample user data. So you can add your DynamoDB resources in the same stack as our Lambda functions. But to show you how to access resources across stacks, I'll create a separate stack for our DynamoDB resources. So within our lib directory, I'll create a new file called dynamodb-stack.ts and paste in empty stack boilerplate code. First, I'll import DynamoDB from CDK lib, which provides all our DynamoDB related CDK constructs. Then I'm importing my CDK context from the types file. And then within my DynamoDB stack class, I'm declaring a public read-only property called ddb table, and the type of this property is ddb.table. We do this because we need our Lambda stack to use this property and provide necessary permissions for our Lambda execution role. This is how you can access the resources across stacks. Then I'm defining my DynamoDB table. I'm setting the name as appname-environment, and I'm getting these values from my context. I'm setting the billing mode as paper requests, and finally setting my partition key as email. And once we create our table, we are assigning it to our public read-only property so that our Lambda stack can use it. We'll see that in a moment. I'm also adding an index on item type so that I can fetch all the users based on item type. That will be helpful if you have different types of entities in your DynamoDB table. Now we need to import and initialize this stack. So let's go back to our entry point TypeScript file. Let's first import the stack and initialize it. I'm calling it appname-dynamodb-stack-environment. Let's save this and deploy again using CDK deploy. The deployment is now complete. Let's quickly check our AWS console. So we can see our DynamoDB table here. Now let's import some sample user data into our DynamoDB table. So I generated some mock users and I have a simple script to import this user data. I'm adding a couple of utility functions to my utils file. So the function getDDB-docline creates a DynamoDB document line to make a connection to our DynamoDB table. DDB batch write function writes items into our DynamoDB table in batches. And DDB write function writes a single item into our table. And DDB delete deletes an item from our DynamoDB table. We'll be using this utility function in all our lambdas. So that's the reason we are adding it to the layer so that we can share these utility functions. Let me execute the import script. If we go back to our DynamoDB table, we can see the user data with email as our hash key. Now let's create schema definitions for our API endpoints. So we'll be using these definitions to validate the payload passed to our API endpoints. As we'll be using these schema definitions in multiple Lambda functions, I'll add the definitions within my Lambda layer. So within my Lambda layer folder, I'll add a file called schema definitions.ts. First, I'm adding a schema for common get parameters like return attributes, next token, and limit. Next, I'm adding the definition to get users. Here I'm spreading common get parameters and adding an additional parameter called email. So that will help us to search on hash key if we want to. It's an optional parameter, so if you don't specify any email, all users will be returned. For add user schema, we need first name, last name, email, gender, and job title and country. And all these attributes are required attributes. And for delete user schema, we just need the email address, as email is our hash key in DynamoDB. Update user schema will be similar to add user schema, except only email is required attribute. So if you pass additional attributes, those respective values will be updated. So those are our schema definitions. Now let's create a function to actually validate our schema. So let me add a new type definition for validation result in our types file. I'm calling it API payload validation result, and it will have isValid as boolean and errors if any. If our payload is valid will be set to true, and if not, it will be set to false. Now let's get back to our schema definitions file and import this new type. Also, I'll be using a package called AJV to validate the schema. AJV is a simple JSON validator, so you're free to use any JSON validator here. Let me first install AJV and corresponding types and import it. Now I'm adding a function called validate-API schema. And this function will take the schema and the data as inputs and returns if the data is valid against the schema. Here we are initializing AJV, compile the schema and validating the data. And based on whether the data is valid or not, we are resolving either true or false. We'll be using this function in our Lambda functions to validate the schema before querying the DynamoDB. I'm also adding type definitions for these schema to use in our Lambda functions. Also, please note that HTTP APIs by default doesn't support request and response validations natively. So that's the reason we're adding our own validation. Now let's put some code in our Lambda functions to perform CRUD operations on the DynamoDB data. So let me paste the code for my getUsers function. I won't be explaining the code line by line here. I'll mention the important bits though. So first we are importing the schema definitions and types required. Note that we are using API Gateway Proxy Handler v2 as our Lambda handler and API Gateway Proxy Result v2 as our return type. Both these types are from AWS Lambda NPM package, which provides us the structure of these events and expected responses from the Lambda function. Here we are fetching the query string parameters from our event, and next we are validating the payload with the function we created in our schema definitions file and passing in the schema and the data. If the payload is valid, we are basically building the DynamoDB query input and setting the required parameters from our payload. Next, we are checking if email is passed in the payload. If it is present, we are querying based on our hash key, which is email. If not, we are just querying on the item type index. And next, we are using our DynamoDB doc client and invoking the query command. And once we get the output, we are setting the response, which will have data as well as the next token, and returning it. Here I am using a couple of utility functions from my Lambda layer called API Success Response and API Error Response. So these two functions make sure that we are returning valid response from our Lambda functions. I added these in the Lambda layer as we'll be using these functions in all our Lambda functions. So that's it for our getUsers function. Let me now paste the code for addUser. So the function structure is similar. In this case, we are fetching the body from the event and validating it against the schema. And once validated, we are building the user object and writing it to DynamoDB using our DDB write utility function. Coming to our delete function, we are first checking if the user is present in our table and using our DDB delete utility function to delete our user based on the email. Within our update user function, we are checking if the user exists based on the email again and building the updated user object based on the payload and using our batch write utility function to update the user in the table. Those are our Lambda functions. I know I went through them pretty quickly. So you can go through the code in the repo and let me know if you have any questions on these Lambda functions. I'll leave the repo link in the description. Now let's create our API authorizer, and we shall be using Cognito as our identity provider. So let's create a stack for our Cognito resources. I'm creating a separate stack for the sake of this demo, but you can include these resources in a single stack as I mentioned earlier. So let me create a new file called cognito-stack.ts under my lib directory and pasting the code for my Cognito stack. As part of this stack, I'm creating two resources. The first one is user pool. I'm just setting the user pool name as appname-environment and setting the removal policy to destroy it, as I want the pool to be deleted when I delete the stack. Be careful when you set this in your production environment. All users within the pool will be deleted along with the pool itself. So for production environments, leave the default, which is retain. Also, I'm assigning this pool to the read-only property within the class, which we'll be using in other stacks. Next, I'm creating the app client and I'm setting the user pool and client name and enabling the user password auth flow. And again, assigning the app client to the read-only property to be used in other stacks. I'm just using the default settings here for these resources. So refer CDK documentation if you want to customize any of these settings for Cognito pool or app client. Now let's import this stack in our entry point TypeScript file. So within my bin directory, I'm importing the stack we just defined and initialize it by setting the stack name, which is appname-cognito stack-environment, and I'm passing in the stack props and context. Now let's do a CDK deploy again and make sure our Cognito resources are created without any issues. All the three stacks are now deployed. So let's quickly jump onto the AWS console and take a look at the new Cognito pool. We have our pool created here, and under app integrations, we have our new app client created. We'll be using this app client to log in and get the token to access the APIs. Now let's create a sample user in our pool so that we can log in and get the token. So I'll use CLI to create the sample user. I'm using Cognito IDP admin create user command and passing in the user pool ID, username, which is demo user in this case, and a temporary password. Our new demo user is created. As you can see, the status is force change password by default. So we can use another CLI command called admin set user password to set the password permanently. I'm again passing the user pool ID, username and a new password. I'm also setting a permanent flag, which will basically set the user status as confirmed. Now if you look at our console, we should have our new user created and the status is set as confirmed and enabled. So that's the config required on our Cognito pool. Now let's create a Lambda function to authorize API requests using Cognito pool. So I'm creating a new file called api-authorizer.ts under my Lambda handlers and pasting the code for the authorizer. I'm using a couple of packages here to fetch Cognito public keys and validate the tokens. So JSON web token package is used to decode the token, which will be passed as authorization header in our API requests. And Axios is used to make call to the Cognito endpoint and fetch the public keys. And JWK to PEM is used to convert the JWK to PEM format. This is because our JWT verify function takes PEM format to validate the token. So let me install these packages and corresponding types. Within the function, I'm just printing the event here and extracting the token from authorization header. And next I'm decoding the token using jwt.decode function. If the decode fails, I'm immediately returning is authorized as false. And if the decode is successful, I'm fetching the public keys from Cognito. I'm making a get call to a region specific Cognito URL with our user pool ID and fetching the jwk.json file. And you can access this URL in the browser to see the public keys. Cognito public keys is an array, so we need to find the key used to generate our token. So we're doing that using the KID attribute within our decoded token. Again, if we can't find the JWK in the well-known JWKs, it means that the token passed in the API request does not belong to our Cognito pool. Hence, we are returning is authorized as false. If we did find the JWK, we are using jwt.verify function to validate the token, and we are passing in the public key converted to PEM format. If we get any error during validation, we are returning is authorized as false, and if it is successful, we are returning it as true. So that's our Lambda function code. Now let's update our Lambda config file to include this new authorizer Lambda function. So in our lambda-config.ts file, I'm adding a new Lambda definition, and the name should be same as the handler file, which is api-authorizer in our case. So we need to add one more environment variable to this Lambda function, which is our user pool ID, as we're using that in our Lambda function. First, let's add a new property called user pool of type user pool to our get Lambda definitions function and import corresponding resource from CDK lib. Now we can extend our environment for our Lambda function to include the user pool ID like this. We need to pass the user pool to our get Lambda definition functions in our Lambda stack. So if we go back to our Lambda stack, we can immediately see an error where we are calling get Lambda definitions function as we are not passing the user pool. Now we don't have access to this user pool within our Lambda stack because the user pool is part of our Cognito stack. So this is where we use that read-only attribute we defined in our Cognito stack. So by default, our Lambda stack constructor accepts stack props, and we need to extend the stack props and add additional props. In this case, we'll be adding user pool. So let's define an interface for our Lambda stack props first. So in our types file, let me add an interface called Lambda stack props, which extends stack props from CDK lib, and it has one additional attribute called user pool of type user pool. So let's import stack props and user pool from CDK lib to get rid of the type errors. Now let's import this Lambda stack props in our Lambda stack and use it instead of default stack props. Now we can pass the user pool to our get Lambda definitions function using props.userpool. Our Lambda stack is fine now, but our main entry point file is red. That's because we need to add the user pool while initializing the Lambda stack. So here we shall just spread the default stack props and add a new property called user pool, and we can access our read-only attribute we defined in our Cognito stack to set the user pool. Now we are ready to deploy our authorizer function with required environment variables. So let's run our CDK deploy again. So the deployment is finished. Let's look at the Lambda function and see if our environment variable is set properly. So we have our API authorizer function created successfully. And if we go to the configuration and click on environment variables, we should see our user pool ID set here. One quick thing we need to do is to provide DynamoDB permissions to our Lambda role, as we'll be accessing our DynamoDB table to fetch and add data from our Lambda functions. So we can do this in different ways. We can update our Lambda role policy here and add a new policy statement with required DynamoDB permissions. But CDK provides some utility functions to define these permissions. To define those utility functions, we need access to our DynamoDB table within Lambda stack where we defined our Lambda role. We can easily do that using Lambda stack props like we just did to get access to user pool within the Lambda stack. So let's add a new property to our Lambda stack props interface and let's call it DDB table, and the type will be a table which we need to import from CDK lib. As you might have guessed, again our main file is red. Let's fix that by adding DDB table property and setting the value as the DDB table read-only attribute from our DynamoDB stack. Coming back to our Lambda stack, we can use the function of DDB table called grant read write data and pass in the Lambda role we defined above. This will add required policies to our Lambda role. Also, you can see that DDB table has different grant functions for different level of access like read write data, full access, etc. Finally, we are ready to define our API endpoints and tie up all the resources we defined till now. I know it's a lot of setup and config, but it's required to create an end-to-end HTTP API. As we'll be creating the API endpoints, which will be backed by Lambda functions, I would like to add the API specific config as well to our Lambda config file. So if we take a look at our current Lambda definition type, we have name, which is required parameter, and we have memory, timeout, and environments as optional parameters. I would like to extend this type to include API specific parameters as well. So I'll add a key called API, which contains path and methods as children. And path is a string, which is the API endpoint path. And methods is a list of required HTTP methods for that path. And I have made this API key optional because we might not want to attach all Lambda functions to an API endpoint. Some of the Lambda functions can be standalone as well. So let's import HTTP method type from CDK lib to get rid of this error. Now let's go to our Lambda config file and add API specific config. So for get users Lambda function, I'll add a key called API and the path will be /users and methods will be get. Let's import HTTP method type again here. And let me add the API settings for other Lambda functions as well. As you can see, I'm using /users as my API path for all Lambda functions, but the HTTP methods are different. For add users, it will be post. For delete users, it will be delete. And for update users, it will be patch. Also, I'm not adding API key for API authorizer because that function is not linked to any API endpoint. So this process of defining the API config will reduce a lot of duplicate code and it will allow us to manage API config from a central location. Now let me create a new stack called API-stack within my lib directory, and I'm pasting the boilerplate code for an empty stack. As we can see, we are receiving the default stack props in our constructor when we initialize this stack, but we need access to all Lambda functions to be able to link the API endpoints and methods to respective Lambda function. So let's create a new interface called API stack props, which extends the default stack props. Within my types file, I'm adding a new interface which contains a map of our Lambda functions, and the key in this map will be the function name and the value will be the Lambda function construct, which is Node.js function in our case. And let's import that from our CDK lib. Now let's import this new interface in our API stack and use it as our props type. If we quickly look at our Lambda stack, we are storing all our Lambda functions in a read-only property here, which is again a map of our Lambda functions. And we'll be passing in this read-only property to our API stack. That's how API stack will get access to Lambda functions. Once we define our Lambda function here, we are adding it to the map with the Lambda name as the key and the Lambda function as the value. Now let's get back to our API stack and start defining our API specific resources. Let's start with the authorizer. I'm pasting the code for our authorizer. And also let me install and add the required imports from CDK. At the time of this recording, HTTP API CDK construct is still in alpha. That is the reason it's a separate package and not within the core CDK lib. It might be soon included as part of the core package. Until then, we need to use this alpha package. HTTP Lambda authorizer takes 3 parameters. First, the ID, which I'm setting it as API authorizer. Next, the Lambda function that you want to act as authorizer, which in our case is API-authorizer. And you can see that I'm accessing the Lambda function from our props object. And the third parameter is the options object, where I'm setting the authorizer name and response type. Next, let's define a custom domain. So this step is optional, as I mentioned earlier. You can use the auto-generated API endpoint URL to access the API if you don't want to use the custom domain. So let's first add the domain and certificate details in our CDK context. The first one is my base domain, which is demodev.keriox.tech. And the second is my API domain, which is prefixed with API dot. And the third attribute is my hosted zone ID. And finally, my regional certificate ARN. Let's also update our CDK context type to include these new attributes, and all these new attributes will be strings. Within our API stack, let's add code for defining custom domain. Also, let me add required imports. Here I'm setting the domain name from CDK context and setting the certificate for our custom domain by importing the certificate using from certificate ARN method and passing in the ARN from CDK context. We also need to create a Route 53 entry for our API domain, so let's do that now. I'm defining a new A record here by setting the zone based on hosted zone ID and base domain. And I'm also setting the record name, which is API domain defined in our context. And finally, an alias target based on regional domain name and regional hosted zone ID. Now let's define our HTTP API. I'm pasting the code for the HTTP API definition and adding required imports. I'm setting the API name as appname-api-environment and setting some description. Then I'm adding the COS config. You can customize these COS restrictions as per your requirements. And then I'm setting our authorizer, which we defined earlier. And finally, we're setting our custom domain. Until now, we have just defined an empty HTTP API. Now we need to add HTTP paths and methods and link them to respective Lambda functions. Let's first fetch the Lambda definitions, where we already defined our API paths and methods. I'm importing the get Lambda definitions function from our Lambda config and fetching the Lambda definitions using this function. Now we can loop through these Lambda definitions and create respective API paths. Let me paste the code first and add necessary imports. Within the loop, I'm first checking if the API key is present in Lambda definition, and if it is present, I'm adding HTTP routes using add routes method present on the HTTP API we defined above. We are setting the path and methods as defined in the Lambda definition. And finally, we are linking the API path and methods to Lambda function using the HTTP Lambda integration. And we are passing in the corresponding Lambda function based on the Lambda name from props object. So this will create all our API paths based on our Lambda definitions. So now let's initialize this stack in our main file under bin directory. I'm importing the new stack first and then initializing it. So you can see that I'm passing in the Lambda functions, which is the read-only property we defined in our Lambda stack. Now we can deploy our stack. Let's do that using CDK deploy. The deployment is now finished. Let's quickly jump on to the AWS console and have a look at our API. We can see that our new regional HTTP API is created. If we click on the API name and go to routes, we have our /users path with all 4 HTTP methods we defined. If we go into authorization, we can see all our methods are pointing to our API authorizer Lambda function. And under integrations, each of these methods will be pointing to respective Lambda function. Also under custom domain names, we can see our custom domain name is mapped to the API gateway domain name with required certificate. So that's our HTTP API. Now that our API is ready to be consumed, let's make some HTTP calls and see if our new API is working as expected. I'll use Postman for these tests. So let's export our API spec so that we can import it directly into Postman instead of creating all these requests manually. So this will save us a lot of time, especially for large APIs. So from the console, click on Export on the side menu here and select the latest config from the drop down. You can include API gateway extensions if you want, but for our testing, we don't need those. So I'm switching off this flag. You can choose the format you want. I'm choosing JSON here. Once you have the file downloaded, you can simply drag it onto Postman and import it. So we have our collection imported. And by default, this exported files doesn't have the custom domain. So you see the default auto-generated API gateway URL as the base URL. As we have defined our custom domain, we can use it. So in my case, it is api.demodev.keriox.tech. So let's first hit our get endpoint without any authorization. As expected, we should get a 401 HTTP response and we get the unauthorized message from the API. So let's get a token from Cognito now and use that as our authorization header. Here I'm using AWS CLI to authenticate our demo user we created in our Cognito pool earlier in this video. Ideally, in production environments, you'll be making this call to Cognito from your front end using Amplify or any other AWS SDKs, where user will be entering their username and passwords on a login screen. As we don't have any front end for this demo, I'm using AWS CLI. I'm using Cognito IDP initiate auth CLI command and setting my region as AP Southeast 2, which is Sydney. And the auth flow will be user password auth. Next, I'm passing in my client ID. And finally, passing in the demo username and password as my auth parameters. So this command gives us the access token, ID token, and refresh tokens. Let's copy the access token and add it to our authorization header in Postman. I'll add this at the parent level so that all child paths and methods can use the same token. So under authorization tab, I'll select bearer token as the type and paste in the token here. Let's go back to our get request and make sure the authorization is set as inherit and hit send. So this time the API request is successful and we can see the list of users returned from our API. And we can also pass in email as a query parameter if you want to fetch a single user. So that's how you can develop and deploy HTTP APIs and corresponding Lambda functions and other resources required. So that's a wrap for this video, guys. Hope you liked it. If you did, please check these other related videos. And don't forget to like and subscribe to my channel. Keep learning. Thanks for watching. See you in the next one.